Good morning, students. Today we're gonna start a new topic, mainly a special topic of this chapter, that is the periodic table chapter, that is anomalous behavior of lithium and beryllium. This is presented by me, Panit Ghatak, your chemistry teacher. So let's begin. In the previous classes, we have already been known that any element present in a particular group shall or should have properties similar to that group elements. Okay, so lithium being an alkali metal, that is, it is present in group number 1. Okay, so in group number 1, which elements we have? Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, so what happens? All of these elements, that is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, all of these elements are called alkali metals. Okay, so lithium is one of them. So all of the elements of these alkali metals, apart from the hydrogen, because hydrogen is not a metal, apart from hydrogen, all of the metals, that is sodium, potassium, rubidium, cesium and francium, all of them especially show some characteristics. Okay, so what is the characteristics of alkali metals? They are only ionic, their melting point is low, their tendency of hydration is low, and their delinquency is no, whereas the delinquency limit is very much less, as well as the solubility is they are soluble in water as well, because they are ionic. As they are ionic, so they are highly soluble in water. Okay, so all of these alkali metals show this kind of properties. But here is the twist. Lithium, as all of the alkali metals are ionic, but lithium is covalent. Similarly, as it is covalent, so the lithium, as we know, the covalent bond is weaker than the ionic bond, so the melting point and boiling point of lithium will be less because it is covalent, and tendency of hydration is high. Okay, and the delinquency limit or delinquency power is very much great in lithium. Okay, and there, as it is lithium is covalent, as the lithium is covalent, not ionic, so it is not soluble in water. As water is ionic, that is H plus and OH minus, or we can also be called as polar. As water is polar or ionic, so it is best for any polar or ionic compound to get dissolved in water. But as lithium is covalent, so it cannot dissolve in water, it only dissolve in organic molecule, okay, or organic compound. So here are certain characteristics that doesn't go with the characteristics of alkali metals. Okay, so lithium have some different characteristics or totally different properties as well. Okay, so that is why, being a alkali metal, lithium doesn't follow the group's characteristics or group's elements, chemical or physical behavior. Okay, that is why lithium shows a anomalous behavior. Okay, so that is, as the lithium is being shown different characteristics other than the alkali metals or the group 1 metals, that is why lithium is being called an anomalous element, or element that shows an anomalous behavior. That is, the elements show different behavior than their corresponding groups elements behavior. Okay, so this is what we call as the anomalous behavior of lithium. Okay, so what is the reason behind that? Okay, actually the reason for the anomalous behavior of lithium is pretty simple. They are extremely small, because the alkali metal or the group 1 element starts from hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium and then francium. Okay, so when we go from top to bottom, radius increases. So as lithium is almost at the top, that is why its radius is very much small, so it is extremely small. As it is extremely small, its ionic potential, that is IP, that is charge by radius, is very much high. As ionic potential is so high, so it has the higher polarizing power. Remember, what is the polarizing power? Polarizing power is to attract the electron sphere or electron cloud towards itself. So what is polarizing power? Polarizing power is the ability to attract the electron cloud towards itself. Higher the ionic potential, higher will be the polarizing power. As the higher the ionic potential, higher will be the polarizing power. Similarly, it has the least electropositive character and non-availability of d orbitals. Non-availability of d orbitals, as lithium doesn't have the d orbitals in it, because we know lithium, what is the atomic number of lithium? Lithium atomic number is 3. So what is the electronic configuration of lithium? Electronic configuration of lithium will be 1:2 2s1. Okay, 1:2 2s1. Okay, so it is the electronic configuration of lithium, and lithium doesn't have any d orbitals. Okay, so that is the reason. This is the 4 reasons behind the anomalous behavior of lithium. Okay, so let's move to the next topic, that is the anomalous behavior of beryllium. Also, beryllium is a group 2 metal. Okay, so beryllium is a group 2 metal or alkaline earth metal. Alkaline earth metal or group 2 metal. In group 2 metal, what we have, that is beryllium, magnesium, calcium, strontium, barium and radium. Okay, so we have these 6 elements in group 2. In group 2. Okay, that is the alkaline earth metal group. And beryllium tops the group. Okay, so beryllium placed in the top of the group. So although beryllium is an alkaline earth metal and present placed in a group 2 metal, group 2 elements group, okay, but it doesn't follow the group's character similar as the lithium. The group behavior in the group elements, general group 2 elements, are mainly ionic, but it is covalent. Maximum coordination number of group 2 elements are 6, but here in case of beryllium it is 4. The oxide and hydroxide's character of group 2 elements are mainly basic, but here it is amphoteric. For beryllium it is amphoteric. So beryllium, we can clearly see that the beryllium doesn't follow the physical and chemical characteristics of the general group 2 elements. Okay, so beryllium shows some different characteristics other than the group 2 elements. Okay, so that is why beryllium is also showing a anomalous behavior. Okay, so beryllium is also called the anomalous element of group 2 metals or group 2 elements. Okay, so what is the reason behind that? We have already discussed the reason behind the anomalous behavior of lithium. Here for beryllium it's also the same. As beryllium tops the group, so here the radius will be less. As the radius is less, so ionic potential will be high. As the ionic potential is high, so polarizing power will be high. As the polarizing power is high, so it shows a covalency. As the covalency, it shows the covalency. That is why all the behavioral change gonna occur. Okay, so number 1 is radius is low, that is a high increase ionic potential, that is why the polarizing power is high. As well as it has the number 4 point is the relatively high electronegativity, and relatively as the electronegativity high, so least electropositivity is least. Okay, and number 5 is it is also beryllium has the atomic number of 4. So what will be the electronic configuration? Its electronic configuration will be 1:2 2s2. So it doesn't have the d orbital at all, similar to the lithium. Okay, so that is why it also shows the anomalous behavior. Okay, right. So we have seen the anomalous behavior of lithium and beryllium, and we have also discussed the reason behind that as well. Okay, so although the reason for lithium and beryllium is also same or almost similar to each other, but their characteristics of the general characteristics of behavioral change are also kind of similar. Okay, that is why their reason behind the anomalous behaviors is also same. Okay, kind of similar, what we can easily say that. Okay, so reason behind the anomalous behavior is basically low size, small size, higher ionic potential, then that is due to higher ionic potential, higher polarizing power. Number 4, least electropositivity, and number 5, absence of d orbitals, okay, or vacant d orbitals. Okay, so that's it for now. I hope you have understood this part very well. If you have any doubt, you can ask your doubts in the comment section below. So thank you very much.